The data team process is comprised of 5 steps. In this video, a 3rd grade team will go through the entire process. It is important to note that for the purposes of providing an effective demonstration, this team held a very thorough discussion on each step. In practice, actual data team meetings can be more succinct in order to fit into the time available at various sites. The first step, charting the data, actually occurs before the meeting, as each teacher prepares their individual assessment data. This can be done in a variety of ways, and it is up to the individual team to decide what is most useful for them. This team uses 3 charts to help analyze their math test data. Some teams may wish to develop their own data charts, but for those that want to dive right in using what is seen here, blank, easy-to-use templates of these charts can be found on the LEA website. First, each teacher fills out a results chart for their own class. The teacher inputs which questions each student missed. At this point, the chart automatically calculates each student's score, as well as how many students missed each individual question. All teachers on the team place their students' names on this chart, which shows which students were advanced, proficient, basic, below basic, and far below basic. Finally, on this chart, each teacher inputs the number of their students who took the test, along with the number of their students who scored proficient or higher. The chart automatically calculates the percentage of each class that scored proficient or higher, as well as the percentage of the entire grade level that scored proficient or higher. Once the data is ready to go, the teachers convene and move on to step 2, analyzing the results. In this step, teachers look at the charted data together and use it to analyze student performance and trends.
Okay, so we're going to do the data team for the multiplication unit, and this is the first time we've given this assessment, and we made the assessment to match what was going to be used for the Common Core and the SBAC questions. So these questions were a little different than the tests that we've used before. We asked students to use multiple methods. We asked them to explain their answers. So given that this data team is our first time going through this test, and it's the first time we've administered this kind of test.
It's really a learning process for us.
Right, right.
Okay, so everybody has input their data?
Yes.
Yes. So let's pull up first this chart.
Okay, so this is a chart that we made for our data teams, and Noah put it together, and it actually computes the percentage of proficient and not proficient. And so you put your the number of students in, how many were proficient. And then we put the names of the students who were not proficient on the test, which we say is 80% or better. And so the yellow column is approaching, so 70% to 79%. The orange is like a below basic, and that's 60 to 69%. And then below 60% is the far below basic, which is the bright pink on the right.
And our goal for the percentage of students proficient on any math assessment is 80. So if we look here, we see that class 1 was 71% proficient or advanced, class 2 was 44%, class 3 was 67%, and class 4 was 35% proficient. So I think they're a little lower than usual because it's a new kind of assessment for us that we haven't done before. It was our first time doing something like this. So we have 2 classes that are pretty much approaching the goal, and then 2 classes that are not so close.
Well, and also this test, we purposefully made it short, so there were only 11 questions. So there, a student could miss 1 or 2 questions, and if they didn't, they could miss multiple points on 1 question. So
they could miss 1 question, and that would knock them completely out of
right,
being proficient.
Right.
Okay, so let's pull up our other chart. This chart shows probably pretty much the same data, but in a different way. On this chart, we actually see the breakdown of students at advanced, proficient, basic, below basic, and far below basic for the 4 different classes. And really, in order to set our goals, we need to be looking at an individual class to see what was missed most frequently.
Mm-hmm.
So,
okay, so this is another chart that actually Noah put together. where it breaks down our, each question item into, we put in a 1 if they missed that. And so if you look at the top, problem number 1 was worth 3 points. 2 of them were methods, and 1 of them was for precision, for getting the right answer. So right now, this chart is sorted into 3 categories. One is, the pink section is the method, the light orange section is actually the answer, and the yellow section is whether the students can explain what they did. So that way we can see areas that we need to focus on our intervention.
This bottom row here shows how many students missed any given item. So that's a very handy row to go across and to see, for instance, where there's a high number like the 8s here, that questions 5, 6, and 7 were the ones that were most frequently missed in my class.
And 10.
And 10.
And if you look at those are, one of them is a multi-step problem, the other 2 are all 2-digit.
So question 5 was this one, the product of 4 times 70. And when I look back at my data, I can see that question 5, doing the method, only 4 students missed that. 8 students missed actually the precision, getting the answer. So what that tells me is that the kids understood how to do this problem. What they didn't have was their multiplication fact. Because most often the incorrect answer would be 4 times 70, and they would have something like 240. And in their explanation they would write, I got that because 4 times 7 is 24. And then I added a 0 because it's 70 and got 240. So that they knew the method of doing 4 times 70, but not the fact.
Okay, so why don't we take a look at another class and see if the results are similar.
Okay, so here's your class. And we can see, for you, the ones that were most missed were 6 and 10. Mine were 5, 6, and 10. So similar. We didn't finish really looking at what those other problems were. So problem 6 was 2-digit by 1-digit, 23 times 6. And problem 10 was also 2-digit by 1-digit. So it does look like, if we look at the 2 classes, it's 2-digit by 1-digit multiplication is the thing that's really needing the most work.
What about the 2-step problem?
2-step problem is, which one was that?
Word number 7, word problem multi-step answer.
Okay, so you had 5 kids miss the answer and 4 kids miss the method. I had 8 kids miss the answer and 5 kids miss the method. And we might as well bring up the 3rd class since we have 3. Okay, so this was one of the classes that had a lower overall percentage proficient. So we're seeing higher numbers down here. But still, the highest numbers are here, problem 6, and here, problem 10.
It seems to be consistent that the 2-digit problems were the most difficult.
Right.
So what do you think about, disregarding the results there, what did you think about the students' explanations?
So I didn't really feel like very many explanations were really, here's how I did the problem. It was more like I didn't count, I used the area model as an explanation.
Right.
I didn't,
Yeah, I got a lot of that too.
and I got that, and especially if it was from our higher students, that, you know, I knew that that wasn't going to make or break them being, you know, in the 90 percentile or whatever. But that other one where they had to explain their favorite part, I mean, why they used their favorite method, most of them just explained how they did the problem again.
Right.
So I don't know if you guys found that, but and then I felt a little bit kind of guilty thinking, you know what, we didn't really practice this, we didn't really ask them to do this, and I'm scoring them down for not doing it.
I think that's exactly right, and what I realized is that we did not make the I didn't anyway, make the expectations clear and really practice, so that children had no idea what a passing answer would be, and I wasn't even super clear on what we were going to accept and not accept.
After looking at and analyzing the data together, the team is ready to move on to step 3, setting goals for reteaching and intervention.
So the next part, having looked at our challenges in the test, the challenges that the students had, we need to set a SMART goal. So the SMART goal is specific, it's measurable, it's achievable, it's relevant, and it's timely. So what do you, given this, where are we going?
Well, definitely we have students who are in the almost proficient category that we can definitely move up into proficient with just a little bit more reteaching and focusing. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 students that we can easily move into proficient with just 2 more questions, 1 or 2 more questions.
Okay, so move our basic kids to proficient.
We'd be at 66%.
If we look at the kids who are, a little further away, like R2, I think that we could definitely get them into proficient.
Right, and I think mine would be able to, I'd be able to move mine to proficient there too.
Yeah.
I think we could probably get all of the basic and below basics to proficient.
If we did that, we'd be at 78% proficient.
So are we still setting the goal of 80%, reaching 80% proficiency?
I think so. I think we should be able relatively easily to get those kids up there. And then if we could get 1 or 2 more from the far belows.
Let's look at the chart that shows all the classes with everybody's name and score.
Okay.
So we've got Gamma is 40. Also Cesar,
Cesar
Diet
and
Francisco.
JC.
So there are
Cesar's
some that are,
Francisco and our,
Each question is 5 points.
right.
it looks like we have 5 kids that are on the higher end of far below.
So are we going to set, what kind of goal do we want to set for the far below basic kids? An increase of
50%.
20%?
Yeah. For each of their scores.
Now, even on those that are at the highest end of far below, if they increase their score by 20%, they won't be at proficient.
Right, I mean, we're going to hope for some, but I think a 20,
20-point gain is pretty
Smart.
oh, 20,
percentage,
not
I'm sorry.
percent points.
So that's 4 questions.
In addition to the specific intervention, I think we'd need to do a whole class intervention with the explanations and two-step problems. Would you call it intervention or whole class review and support? Or?
Explanations would be tier 1, that'd be the first time we're teaching it. But the 2x1 will be, or the 2-step will be intervention.
Do we want to come up with some frames for the explanations?
Sentence frames, like I solved this by.
And I know my answer is right because.
Yeah.
So,
I think also when we're explicitly teaching this, that you can have showing some examples of, how, what is and what is not, so that they can see the difference between, looking at what some of these explanations are that we got, but
Model.
yeah, so that they can see and understand what the difference is.
Once the goals have been set, the team is ready to move on to step 4, where they will select effective teaching strategies to help them meet these goals.
okay, so the next thing that we need to do is to select effective teaching strategies. So the whole point of this is that we improve our teaching. So we look at the data and we say, if we were successful at a certain problem or certain skill, then we want to share that and we want to put that skill, strategy into our repertoire, in particular since we're using it in intervention.
So do we want to look at specific problems that we have some strategies for, or look at a class that's more successful and hear from them what they did to get?
Well, let's pull up your data so you can ask a specific question. Here's your class.
So my hardest hit problems were the word problem with the two-digit answer, and the times 70.
So I noticed, just to start, that this times 70 was a challenge for many students in most of the classes. And then I'm trying to think, how did we teach that? What was?
And I know one way I showed them was to do, the question was 4 times 70, right? So I showed them 4 times 7, and then they could take the zeros from those two factors and just move them into the answer. So they all saw that 4 times 7 was, they all should have seen that 4 times 7 was 24. 28, and then add the 0. But with the amount of kids that still missed the answer, which was about half of them, there was a lapse in there from that.
Yeah, and I also had a lot of kids who added 74 times and then made mistakes when they were adding their sevens. So same thing, they didn't know what 4 times 7 was.
So, I'm still gonna say, like I said before, that we really need to be working those multiplication facts. Because
Right.
that was the thing that was holding most of the kids back on that problem.
Yes.
Was just not knowing 4 times 7. The way I taught multiplying by multiples of 10 was a lot like what you did, except I did a pattern. I wrote up on the board 4 times 7 equals 28, 4 times 70 equals 280, 4 times 700 equals 2,800, 4 times 7,000 equals 28,000. And we looked at the pattern that each time we were seeing the 28, and then the number of zeros after the 1, like 1 0 in 10, 2 zeros in 100, that was the number of zeros in the answer after the 28. And so the pattern is what taught the skill.
So I had my students come to the floor with their notebooks and with their math notebooks, and we took the paper and folded it in half and folded it in half again, so I had 4 columns. So I started off with what they knew, which is, times 10, like 5 times 10 and 6 times 10, and then we just kind of went down that column, and then I said, okay, so what would 9 times 10? They got that. And then I said, okay, what about 15 times 10? And then I had them talk in their groups. So they did a little bit of sort of an inquiry method. That, after I did the set, everything times just 10, I did that for 2 days. Times 10, times 100, times 1,000. And after the 2 days, then I did multiples of 10. So like 20 times 7 and 30 times 7. So
She's been 2 days just doing the times 10.
right, well, and times, again, just with a 1, 10, 100, 1,000. So then they really had internalized that pattern and the rule of the zeros before we added the other variable of the knowing the fact.
That's really good. Yeah, I just jumped right in and went straight to multiples of 10.
I was in the middle. I did 1 day of just the 10, 100, and 1,000, and then the next day we went into those other numbers.
And I think thinking about how the classes panned out, that time and the repetition
It's well spent, yeah.
is well spent.
Well, and this group that we have is so much lower than the group we had last year. I have to keep reminding myself that they need more support.
Yeah, and what's interesting is you spent 2 days on that foundational skill. I spent 1 day. You didn't.
Not that founded, yeah.
And then on that problem hour 3 classes, the data shows that your kids got the most right, and mine the next most, and yours the next most. So that would really suggest that was important.
Yeah.
Finally, the team moves on to Step 5, determining results indicators. In this step, they agree upon measures that will be used to determine success on the goals.
So the 5th step in the process is determining results indicators, which just basically means how are we going to know if we've met our goals. And that, for this particular data team, I think that's simple. We're going to give a retest, but we need to decide when we're going to do that.
Are we going to give everyone the test again?
I think yes, because we're doing a whole class intervention for part of our...
Right, so then if we change the problem, it wouldn't matter.
But not those who got 100%.
Right.
We hope that this video proves helpful as you begin to explore the strategy of data team meetings. For more information, we recommend Chapter 8 in Larry Ainsworth's book, Common Formative Assessments, as well as Angela Peary's book, The Data Team's Experience, A Guide for Effective Meetings.